Thank you once again to you, my boys and girls. My channel's name is Vidyut Flow. You may subscribe if you like it. After a long time, I face you due to some unavoidable circumstances presented in my life. So, don't worry, I am going to my destination, and today's class is of class 12 IIT-JEE preliminary level atomic nucleus. We shall solve this chapter in one shot only. This is the first program which says to us the ratio of the densities of a nucleus and water is given as four answers here. Given mass of each nucleon this, and R0 is the 1.2 into 10 to the power minus 15 meter. What is R0? Is the constant which is related to the atomic mass number for nucleus as R equals to R0 a to the power 1/3, where is the mass number of a nucleus. This relation comes from nuclear science or atomic nucleus chapter. So here we answer. In answer to this question, you can write the density of the nucleus equals to, what is this? This is the mass number and multiplied by the mass of each nucleon, and this divided by volume, you know it. So A into 1.67 into 10 to the power minus 27, this divided by 4/3 pi into this, and now 1.67 into 10 to the power minus 27, this divided by 3.14 into R0 cube means 1.2 into 10 to the power minus 15 whole cube into A, where A cut out. So this is 3 into 1.67 into 10 to the power minus 27 plus 45, this divided by 4 into 3.14 into 1.2 into 1.2 into 1.2 equals to 1.67, this divided by 3 4 12, 0.4 4 16, this into 1.44 into 3.14 into 10 to the power 18. So this is, on simplification, you get 1.67 by taking calculator here. Seven point 23456 into 10 to the power 18 equals to 0.23 into 10 to the power 18, which is equals to 2.3 into this into 10 and this divided by 10. You get this into 10. 0.23 into 10 gives you 2.3 and this divided by 10 it gives you 10 to the power 17. Now the ratio of density, we know the density of water equals to 10 cube kg per meter cube. We know it. So the required answer equals to this one 2.3 into 10 to the power 17, this divided by 10 to the power cube equals to 2.3 into 10 to the power 14. So answer equals to B. Number 2 problem, half-life of a radioactive isotope A is 50 Y, means 50 years. It decays into another stable element B. The two elements A and B are found to be in the ratio 1:16 in a sample of a rock. Then the age of the rock. We know n equals to n0 e to the power minus lambda t, where lambda is the disintegration constant and n0 is the primary nucleus at time t0. So this can be written as n0 into e to the power minus 0.693, this divided by t into t, and this is equals to e to the power minus 0.693 whole to the power t by t, and this is equals to half to the power t by 2. We know e to the power minus 0.693 equals to half. You can get it by calculator. So here n equals to this, and now n by n0 from the problem we get n by n0 equals to 1 by 16. So here we get 1 by 61, half implies 1 by 16 equals to half to the power t by capital T, which is half life. So implies half to the power t by 50 equals to half to the power 4, implies t by 50 equals to 4, implies t equals to do so. So answer equals to B. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. At time t equals 0, number of P species are 4 and 0. What is the number? Number of nuclei present at the P species equals to this, and that of Q are this. Half-life of P for conversion to R. P is converted into R, also Q is converted into R, is 1 minute, whereas that of Q is 2 minutes. Initially there are no nuclei of R present in the sample. When number of nuclei of P and Q are equal, the number of nuclei of R present in the sample would be this. 4 answers given. Here, what is the problem? P converts into R also. Q converts into R. And for P, we get when number of this line. This line, you first attack this line, which is last line. So NP equals to NQ given. The number of P species and number of Q species are equivalent. So what is NP? NP equals to 4N0, because we know from this relation N equals to N0 e to the power minus e to the half t to the power half to the power t by t. Why this relation is applied? Because half-life given here. We know at the previous problem that this can be written as n equals to n0 e to the power minus lambda t, which where this is converted into this. So this is equals to n0 half t upon capital T. What is the capital T is equals to 1, and nq equals to n0 half t by 2 implies 4n0 half to the power t equals to n0 half to the power t by 2. What is the t? Well, t is the time at which np equals to nq. So we can write half to the power t equals to 1 by 2 whole square into half to the power t by 2 equals to half to the power 2 plus t by 2. Half to the power t, this divided by half to the power t by 2 equals to half square, implies half to the power t minus t by 2 equals to half square, implies t by 2 equals to 2, implies t equals to 4. So after 4 minutes, np will be equals to nq. Now after 4 minutes, what will be the amount of R from P? So amount of R from P species will be so after 4 minutes np equals to nq, and np equals to 4n0 up to the power 4 equals to n0 by 4. So this will be at first total number of P species equals to 4n0. So 4n0 minus of n0 by 4, and R from Q species This will be equals to n0 minus n0 by 4, and this is equals to so total of R. So answer will be C. This is a problem. Find out the expression for mean life or average life of a radioactive substance. The expression we know, which is equals to tau equals to 1 by lambda. We would find this value where lambda is the disintegration constant. This is in between a preliminary and subjective. In between these 2 points, this problem lies. I suppose that this problem should be answered here. So I am answering this problem. We know dn dt equals to minus lambda n. This is a standing radioactive equation from which we start our lesson. Tau equals to 0 to infinity t dn, this divided by dn, 0 to infinity. Why this? Because we are going to find the average time. So t dn equals to the number of disintegration at time t, and dn is the total number of disintegration. So total number of disintegration at time t. So from this we get t dn upon dn. We cutting out, we get t. So we get average value in this way. If we find an average value, mean value of x, so this, so which what we get, which you get by x suppose x dm, this divided by dm. So dm cut out, we get the value of x, which is in this also here we get this type of relation for average and mean value. Now put this now by straight integration, definite integral, we can find t and dn. From this dn we get minus lambda n dt. So t and dn, then minus lambda n dt, this divided by 0 to infinity minus lambda n dt. Now minus lambda t, n equals to n0 e to the power minus lambda t dt, this divided by 0 into minus lambda n0 e to the power minus lambda t into dt. Because we know n equals to n0 e to the power minus lambda t. From this, by calculating suppose this minus lambda dt, both integrating both sides, we get log n equals to minus lambda t plus c, where c is the constant, so log n equals to minus lambda log n0 when t equals to t0. So this is 0. When t equals 0, then the total number of nuclei present at the time of t equals 0 equals to n0, you know. So from which we get c equal to log n0. Put here, we get log n equals to minus lambda t plus log n0. Changing side, we get n by n0 log of this equals to minus lambda t, from which we get n by n0 equals to e to the power minus lambda, which is the Aparian constant, Aparian base, from which we get n equals to n0 e to the power minus lambda t, which, and this relation is applied here. So this is equals to minus lambda cutting out, because this is constant, n0 is cutting out. So 0 to infinity t e to the power minus lambda t dt, this divided by 0 to infinity e to the power minus lambda t dt. Now tau equals to, integrating by parts, we know uv dx equals to u integral v dx minus integral du dx v dx dx. This is the integration by parts, where u is a function of x and v is also a function of x. So applying this, taking t as first function and e to the minus t, e to the minus lambda as second function, we get tau is equals to u integral e to the power minus lambda t upon minus lambda into the minus d to 1 into e to the power minus lambda t upon minus lambda dt. The limits of it is 0 to infinity, and this is equals to e to the power minus lambda t upon minus lambda, also 0 to infinity, equals to, taking 1 by minus of this common, we get t e to the power minus lambda t minus lambda upon minus lambda 0 to infinity, this divided by 1 by this to the power minus lambda t 0 to infinity. Equals to, this is cutting out, this is plus. So first applying the upper limit of integration, we get e to the power this equals to 0, because e to the power minus lambda into infinity equals to 1 by e to the power lambda infinity equals to 0. So this one is 0 minus of 0. 0 minus, when t equals to 0, we get this is 0, and plus this is minus. 1 by lambda. This divided by 0 minus when put infinity we get e to the power we get e to the minus lambda into infinity minus e to the power minus lambda into 0. So we get minus 1 by lambda, this is 0 minus e to the power 0 equals to 1, so 1. So we get 1 by lambda. So tau equals to 1 by lambda. A proton is bombarded over a lithium nucleus. Due to collision, two alpha particles are produced. A proton is bombarding a rest nucleus of lithium. A lithium nucleus is at rest position. Due to collision, two alpha particles are produced as per figure given. Because these are two alpha particles, so their masses are same, and because the theta given as the same, so their velocity will be also same. Why velocity is same? This kinetic energy half mv square, this kinetic energy also will be the same because their angle of direction are same. So if direction of motion of the alpha particles is at an angle of this with the direction bombarding proton, then the correct relation between kinetic energy of proton and that of alpha particle is given. What will be the answer? From the conservation of momentum, we can write from conservation of momentum, we can write Pp plus P lithium equals to 2 root over twice m alpha k alpha into cos theta. Why this written as the right hand side? Because there is if we resolve this alpha particle into two parts, one is along the horizontal direction and another one is at a vertical direction. The vertical part will be cancelled out and horizontal part will be added. So here is 2, and why this? We know P we know K alpha equals to half m alpha into V alpha square. Put m alpha here, multiplying both sides, we get this. So twice m alpha k alpha equals to m alpha V alpha square, from which we get P alpha equals root over twice m alpha k alpha. So put here this, and because the lithium nucleus is at rest position, so twice mp kp, also applying this relation, we get 2 root over twice m alpha k alpha into cos theta equal to 1 by 4, because this implies cos theta equals to 1 by 4. Now we know m alpha equals to 4 times mp. M alpha is the mass number of alpha particle, and mp is the mass of a proton. We know the mass of a alpha particle, which is known as doubly ionized helium atom, that is the nucleus of helium atom, and that nucleus is of mass number 4, which is almost the mass 4 mp, because there is a 2 proton, 2 electron, 2 neutron and 2 proton, and then proton and neutron are of almost same mass, so we can write m alpha equals to 4 mp, from which we can write twice mp kp equals to 2 root over twice into 4 mp k alpha into 1 by 4. From this we get 4 root over 2 mp k alpha into 1 by 4 twice mp kp. By squaring both sides we get twice mp kp equals to twice mp k alpha. So cutting this we get kp equals to k alpha. So answer D. In a radioactive substance, a number of particles decay in the first 2 seconds, and 0.5 n particles decay in the next 12 seconds. The mean life of the substance is this. 4 answers given here. We have the relation, we have the standing relation as n equals to n0 e to the power minus lambda t, where n0 is the primary number of nuclei at time t equals to 0, and n is the number of nuclei at time t equals to t. So the disintegrated number of nuclei is not this term. This term is the residual nuclei. Here n is the disintegrated number of nuclei, and also 0.5 n also disintegrated number of nuclei. বাংলায় বলে বিঘটিত সংখ্যা, বিঘটিত নিউক্লিয়াসের সংখ্যা হচ্ছে এগুলো n আর 0.5. এখানে রিলেশন আছে nটা হচ্ছে অবিঘটিত সংখ্যা, which is undisintegrated number of nuclei. So we can write as n1 answer. Suppose after first disintegration the number remains n1, so n1 equals to n0 e to the power minus lambda into 2, and n2 equals to n0 e to the power minus 4 lambda. Now, according to problem, n equals to n0 minus n1 and 1.5 n equals to n0 minus n2. So we can write as n equals to n0 minus n0 to the power minus twice lambda, and n0 minus n0 to the power minus 4 lambda equals to n0 common 1 minus e to the power minus twice lambda, and this is equal to n0 1 minus e to the minus 4 lambda. So we can write by dividing 1 and 2. Solving 1 and 2, we can write 1.5 upon 1.5 equals to 1 minus e to the power minus 4 lambda, this divided by 1 minus e to the power minus twice lambda. Implies (1.5) minus 1.5 e to the power minus twice lambda equals to 1 minus e to the power minus 4 lambda. Changing side, we get 1.5 e to the power minus twice lambda minus 4 lambda. Zero point 0.5. E to the minus twice lambda whole square minus 1.5 e to the minus twice lambda equals to 0. So this is a quadratic equation of e to the minus twice lambda. We can e to the minus twice lambda equals to a put. So we get a square minus 1.5a plus 0.5 equals to 0. A square minus 10 square minus 15a plus 5 equals to 0, or 3a square minus 3a plus 1 equals to 0. 2a square minus 3a plus 1, so 2a square minus 2a minus a plus 1 equals to 0. We get a minus 1 common, a minus 1 equals to 0, or a minus 1 2a minus 1 equals to 0. We get a equals to 1 and a equals to half. So from here we get, for a equals to 1, we get e to the power minus twice lambda equals to 1 equals to e to the power 0, implies lambda equals to 0, which is impossible because disintegration constant cannot be 0, which is impossible. So e to the power minus twice lambda equals to half, implies minus twice lambda equals to ln half, implies lambda equals to minus ln half upon 2. And mean life, so the mean life equals to 1 by lambda equals to minus 2 upon ln half, minus 2 upon ln half. So answer A. A stationary thorium nucleus within bracket A equals to 220 and Z equals to 90. Where is the mass number and Z is the atomic number? You know, emits an alpha particle with kinetic energy E alpha. What is the kinetic energy of the remaining nucleus? Suppose this is a nucleus of thorium nucleus which has 220, 90. So this is when it minus alpha, it emits 2, suppose it emits, this one is so minus alpha implies কি ইমপ্লাই করছে এখানে একটা আলফা emits an alpha particle with kinetic energy, emits an alpha particle. So we can write emits number 1 alpha particle and number 2 remaining thorium nucleus. Remaining thorium nucleus. So if we consider the conservation of momentum, then we can write as 0 equals to root over twice m alpha E alpha minus root over twice m thorium dash E thorium dash. We suppose the remaining thorium nucleus as thorium dash. Why minus sign? Because this is the remaining the before action momentum of thorium nucleus equals 0. So after action, the total momentum, total resultant after action resultant momentum will also be 0. So minus sign gives you, we get from here E alpha E thorium dash upon E alpha equals to m alpha m thorium dash. Now m alpha, what is alpha? Alpha is the doubly ionized helium atom. Suppose so in a nucleus 2 proton and 2 neutron present, so we can write m alpha as 4 mp. The mass of proton and mass of neutron are almost equal to each other. So and also m thorium dash will be 1 alpha emits from thorium. So there is a subtraction of mass number from 220 to 4. So this will be 216 mp and atomic number is inactive in this position, in this case. So we can write as 4 mp, this divided by 216 mp. We get 1 by 54. So after all we can write E thorium dash equals to E alpha upon 54. So E alpha upon 54, answer D. Boron has 2 isotopes, B10 and B11. Atomic weight of boron is 10.81. The ratio of the 2 isotopes in nature is this. 4 answers given. We know atomic weight as by the mathematical relation. Suppose X% of B10 presents in nature. So 100 minus X% of B11 presents in nature. So you can write X into here 10 is the mass number of a proton of a atom of boron. X into 10 plus 100 minus X whole into 11. This divided by 100 equals to 10.81. So we write 10x minus 11x plus 1100 equals to 281 implies x equals to 19. अतएव B10 presents in nature upon B11 presents in nature equals to 19 upon 100 minus 19 equals to 19 upon 81. So this one is the answer D. So this is all about our today's class. We shall meet you in the next class. And you may subscribe my channel if you like it. The answers solved here to the best of my knowledge and belief with a lucid manner. Thank you.